guys, welcome back to my channel. It's Teacher Raph. This is Twilight Zone episode 92. Well, I've been trying to wrap my mind around the fact that 50 to 60 degrees of temperatures plummeted in 1, 2, 3 days, pretty much overnight in southern Texas, which just makes zero sense to me. So I started looking at more of these Texas local news videos and reading some comments, which led me to formulate two hypotheses. It's not normal, it's not natural, and it must be cloud seeding. And if that's true, which I'd have to look into because I don't know that much about it, then the question would remain, is someone doing this on purpose? Cloud seeding, right? Okay, I don't know. Here's the second thing. I learned that the North Pole is actually shifting. It's shifting and shifting and shifting. And for whatever reason, if it's the cause of a severe icy winter overnight plummeting southern Texas, then it is a big deal because it's changing climate around the world. And, you know, I started thinking all of these people are arguing about climate change, and people are discussing if it's real, if it's not real, what's causing it, what's not causing it. I would have imagined that actual scientists, instead of politicians, would have come to the front and said, hey, our North Pole is shifting, so therefore the entire globe is going to shift its climate. I mean, that seems pretty logical to me, right? I mean, we all know pollution exists, and industry creates pollution and it warms the earth. We all know that. But in terms of the magnetic pole shifting, that's a huge, huge deal. It could plummet the earth into an ice age. Who knows what it's capable of? Let's take a look at some of this. So if the North Pole is moving across the world from Canada toward Russia, toward Siberia, then that means many hot places are going to be cold and many cold places are going to become hot. So that would logically become a drastic effect on many species. Many species are going to go extinct. Many people are going to become very poor because upgrading houses and roads is very costly. Winterization of everything, that's going to take years, and people are in the dark, literally and figuratively, about this because no one even knows it's happening. And look at this article. This article came out in 2019. I have heard of a theory that the North Pole will shift 4 degrees. I've heard about this for a long time, and people were very scared that it would trigger earthquakes, but I haven't read much about it. And now I'm looking into it and thinking, how come politicians haven't been allowing us to know about this? How come they haven't been plugging this idea? How come they haven't been preaching this idea? All we ever hear about is that the North Pole caps, the ice caps are melting, but no one's talking about the balance of this. What's the other balance of it? That ice is going to start being created on the other side of the world, right? Wherever that may lie. I don't know how that's going to end up, but we're hearing about climate change and they're like making us scared of it. I mean, some of us who are listening to this, but they're not doing anything about it. They're not saying, hey, let's winterize this part of the country or this part of the world. Let's not winterize this part of the world because it's going to become 100 degrees. I mean, think about this. If Texas is going to be cold and from now on it's going to have ice storms in the southern end of Texas, that's right by Mexico's border? Think about this. What does that mean? Is it getting is all of that cold going toward Nevada and Arizona? Is that what's happening? I mean, I'm just asking because it just doesn't even make sense. So if that's true, then all of those homes better start winterizing right now, because in a few years they're going to be hit with a storm like Texas's, and no one's even talking about it. No one's talking about it. They're just talking about nonsense like climate change, but they're not saying what does that actually translate to? What does that mean? What are the effects of that cause? An article here. Magnetic North Pole is rapidly moving because of some blobs. Okay, it started in Canada, now it's inching closer to Siberia. And this was written in 2020. Ever since James Clark Ross first identified it on the Bothia Peninsula in Canada's Nunavut territory in 1831, scientists have been carefully measuring its location ever since. But in recent years, it's been inching closer and closer to Siberia at a surprisingly rapid pace. Now researchers from UK and Denmark say they've uncovered the reason for this mysterious movement. Two writhing lobes of magnetic force are duking it out near Earth's core. The wandering of Earth's north magnetic pole, the location where the magnetic field points vertically downwards, has long been a topic of scientific fascination, the researchers write in their paper, which appears in the May 5th issue of Nature Geoscience. Earth's magnetic field is generated by molten iron in its outer core. The flow of this liquid iron can influence the location of the planet's magnetic poles. While poles have drifted and even swapped places numerous times over the course of Earth's long history, what's different about this recent shift is how quickly it's happening. From 1999 to 2005, Earth's magnetic North Pole went from shifting 9 miles at most each year to as much as 37 miles in a year. These scientists poured over 20 years of satellite data from the European Space Administration's Swarm satellite mission and discovered that over the last 2 decades, the position of the North Magnetic Pole has been largely determined by 2 large-scale lobes of negative magnetic flux on the core mantle boundary under Canada and Siberia, according to the study. Between 1970 and 1999, the flow of molten magnetic material in Earth's outer core changed. Because of these changes, the researchers say the magnetic blob lurking beneath Canada slowly elongated in the early aughts, weakening the corresponding magnetic intensity on Earth's surface. Eventually, the blob of molten material beneath Canada split in two, and the stronger one slowly shifted toward the blob beneath Siberia. This spurred the magnetic North Pole to slip closer and closer to Siberia, where the magnetic intensity was stronger. In 2017, the magnetic North Pole fell within 240 miles of the geographic North Pole. The movement has been so rapid that the British Geological Survey and U.S. National Geophysical Data Center, which update the world's magnetic model, had to accelerate their process in order to keep up. The scientists generated a series of models of Earth's core in an effort to understand how it might move in the future. Our predictions are that the pole will continue to move towards Siberia, but forecasting the future is challenging and cannot be sure. The study's lead author, geophysicist Phil Livermore of the University of Leeds, told Live Science, "These shifts have major consequences for global navigation on systems. Anything or anyone that uses a compass, from ships at sea to smartphones in our pockets, is impacted by this magnetic game of tug of war." So it appears to me that the military has known about this, and they're probably prepared because of course they are. They're intelligent. As magnetic North Pole zooms towards Siberia, scientists update World Magnetic Model, published February 4, 2019. North is on the move, and that's a problem for your smartphone's maps. Earth's geographic North Pole is fixed, but the planet's magnetic North Pole, the north that your compass points toward, wanders in the direction of Siberia at a rate of more than 34 miles per year. That movement may seem slow, but it has forced scientists to update their model of Earth's magnetic field a year earlier than expected so that navigational services, including map-based phone apps, continue to work accurately. The drift results from processes taking place at the center of the planet. Molten iron and nickel slosh and spin in the planet's core, essentially serving as a metallic conductor for Earth's magnetic field. Changes in that fluid flow lead to changes in the magnetic field. As a result of those changes, the accuracy of the National Oceanic and Atmospheric Administration's World Magnetic Model, WMM, a mathematical representation of the magnetic field, slowly deteriorates in the 5-year periods between updates. The next update was due in 2020, but unplanned variations have degraded the quality of the WMM so greatly that NOAA published an out-of-cycle update Monday. It was delayed from January by the partial government shutdown. Researchers had known that the model was in trouble for about a year, Nature reports. Arnaud Choulet, a magnetist for NOAA, spoke to a meeting of the American Geophysical Union last year about realizing how inaccurate the model had become. That was an interesting situation we found ourselves in, said Choulet. What's happening? The explanation was twofold, he said. The pole's continuous movement away from the Canadian Arctic was a problem for the model as usual. Add in a 2016 geomagnetic pulse beneath South America that shifted the magnetic field, and you had a model too inaccurate to wait for next year's update. The new version of the WMM should stay relatively accurate until 2020 update comes out as planned. Well, we're already in 2021, and I haven't found any other articles besides just a handful. The early release is good news. Okay. Let's see. Is there another article? Polar Express magnetic North Pole speeds towards Russia. Surge effects navigation is believed to be caused by a jet stream in Earth's liquid outer core. This was written in 2019. Shift has caught scientists' attention and forced them to take rare action. Concerned for those who navigate in the Arctic regions, they have updated the official map of the world's magnetic field to pinpoint the pole's location. We know from old ship's logs that in the past 400 years, the North Magnetic Pole has hung around northern Canada until the 1900s. It moved perhaps tens of kilometers back and forth, said Cyrian Began, a geophysicist at the British Geological Survey in Edinburgh. But in the past 50 years, it started to move north, and in the past 30 years, it started to accelerate away. He said it went from moving at about 5 to 10 kilometers, 6 miles a year, to 50, 60 kilometers a year today. It's now moving rapidly towards Siberia. The North Magnetic Pole is moving about 34 miles a year. Okay, the World Magnetic Model tracks the positions of Earth's magnetic poles funded by the US-UK military. The model is normally updated every 5 years, but the next update scheduled for next year has brought forward because of North Magnetic Pole's recent movements. We'd realized that particularly up around the North Magnetic Pole, the errors in the model had become too large for it to be useful, said Began, who works on the model. The wandering pole mostly affects those navigating in the Arctic. If GPS systems fail, pilots on planes and ships fall back on compass navigation and so need up-to-date maps on their onboard computers. At high altitudes, the U.S. military has named airport runways after their direction in relation to magnetic north and changes them whenever the poles move. For example, the airport in Fairbanks, Alaska, renamed the 1L-19R runway 2L-20R in 2009. A similar map based on the WMM is used by smartphones and car sat-navs to work out what direction they are facing. But below the northern tip of Scotland, at latitudes lower than about 55 degrees, the pole's recent movement does not make a drastic difference. The correlation is only a fraction of a degree, and most sensors are only accurate to within a few degrees to begin with, said Began. For most WMM users, the difference between the old model and the 2019 version would be barely perceptible. He said it's mainly for people who need very accurate measurements, particularly if they are going up to the North Pole. While the North Magnetic Pole marks the northern focus of the planet's magnetic field, the geographic North Pole marks the northern tip of the axis Earth rotates around. The pole's recent travels are believed to be caused by the formation of a narrow stream, much like the jet stream in the atmosphere in the Earth's liquid outer core. The iron-nickel core is so hot that it flows like water 1869 miles beneath the surface, creating the magnetic field and dragging it around the planet. The North Magnetic Pole has been caught up in this jet, and it's pushing it rapidly across to Siberia. The South Magnetic Pole is moving far more slowly than the North, because the liquid outer core is moving differently in the southern hemisphere. At the moment, Earth's magnetic field is growing steadily weaker, leading scientists to think it will eventually flip, with the north and south poles changing places like a bar magnet flipping over. Oh boy. Researchers know from traces left if rocks that this has happened before, but not in the past 780,000 years. It's not a question of if it's going to reverse. The question is when it's going to reverse, said Daniel Lathrop, a geophysicist at the University of Maryland. Such a flip would not be instantaneous, but would take 1,000 or more years to play out. So we're in the middle of this flip, right? Lathrop believes the flip will come sooner rather than later because of the weakening of the magnetic field and the fact that an area in the South Atlantic has already reversed beneath Earth's surface. Began said this magnetic field's movement and the rise and fall in its strength are all part of its natural behavior in the long term. He said the movement of the north magnetic field could become noticeable because it affects where aurora, such as the northern lights, can be seen. The aurora is centered around the north magnetic pole in a ring, so as the pole moves, the aurora will follow it, he said. It's titled World Magnetic Model 2020, released by the National Centers for Environmental Information, National Oceanic and Atmospheric Administration, December 10th, 2019. The latest version of the WMM, one of the key tools developed to model the change in Earth's magnetic field, has been released, developed by NCEI and the British Geological Survey with support from the Cooperative Institute for Research in Environmental Sciences. The WMM is a representation of the planet's magnetic field that gives compasses dependable accuracy. The WMM now includes a blackout zones around the magnetic poles as defined by the strength of the horizontal field. Between 2,000 and 6,000 nanotesla NT horizontal field strength is the caution zone, where compasses may start to become prone to errors. The area around the pole between 2,000 and ONT is the unreliable zone, where compasses may become inaccurate. Smartphone and consumer electronics companies rely on the WMM to provide consumers with accurate compass apps, maps, and GPS services. The WMM is also the standard navigation tool for the Federal Aviation Administration, U.S. Department of Defense, North Atlantic Treaty Organization, and more. A new and updated version of the WMM is released every 5 years. The latest 2020 model will extend to 2025. Drifting poles. Since Earth's magnetic field is created by its moving molten iron core, its poles aren't stationary, and they wander independently of each other. Since its first formal discovery in 1831, magnetic pole has traveled around 14,000 miles. This wandering has been generally quite slow, allowing scientists to keep track of its position fairly easily. Since the turn of the century, the speed has increased. Continued drift toward Russia, although at slowly decreasing speed down to about 40 kilometers, compared to the average speed of 55 over the past 20 years. The military uses WMM for undersea and aircraft navigation, parachute deployment, and more. Other governmental organizations such as NASA, the Federal Aviation Administration, U.S. Forest Service, and many more use the technologies for surveying and mapping, satellite antenna tracking, and air traffic management. Airport runways are perhaps the most visible example of a navigation aid updated to match shifts in Earth's magnetic field. Airports around the country use the data to give runways numerical names, which pilots refer to on the ground. The declination has changed just over 2.5 degrees over the past 22 years since Denver opened. Heath Montgomery, the international airport's former spokesperson, said after a previous WMM. Thanks for listening. Hit like, hit subscribe, leave a comment, and remember, be safe.